In this lecture, we focus on two particular phenomena within superconductors, the intermediate state and the mixed state. First, we need to understand what demagnetization is. Let's assume there is a long solenoid magnet with a superconducting sphere at its center. Since a superconductor is perfectly diamagnetic, the flux lines inside the superconducting sphere are expelled as the figure below. Then, using Ampere's law, we can easily prove that the magnetic field strength inside the superconductor exceeds the applied external magnetic field. This phenomenon is called the demagnetization of a superconductor. Let's consider a specific case involving a superconducting ellipsoid. Here, the magnetic field inside the ellipsoid has a defined relationship with the applied field, mediated by the demagnetization coefficient, n, which ranges between 0 and 1. However, we encounter an issue where the magnetic field inside the ellipsoid can reach its critical magnetic field at an applied field strength that is lower than the critical magnetic field. We will discuss how to address this complication in the following slide. When the applied magnetic field is gradually increased, such that the field inside the superconductor reaches the critical magnetic field, the superconductor enters the intermediate state. This state is characterized by a partial transition to the normal state, with the superconductor dividing into normal and superconducting regions. The precise value of the magnetic field that induces this state varies depending on the shape and orientation of the superconductor. A real-life depiction of the intermediate state, demonstrated using iron powder and an aluminum plate, is illustrated in the figure. Here, we discuss a different phenomenon called the mixed state. The mixed state occurs when quantized flux penetrates into the superconductor, forming a Fluxon lattice. This mixed state is energetically favorable for the superconductor and creates normal state islands within the superconducting matrix, a key distinction from the intermediate state we discussed earlier. To summarize, the intermediate state and the mixed state are two different responses of superconductors to external magnetic fields. The intermediate state involves a mixture of normal and superconducting regions, while the mixed state is characterized by the penetration of quantized flux. Understanding these states is crucial for the design and implementation of superconducting materials and technology. Stay tuned for our next chapter, where we'll delve deeper into the conditions that give rise to these states.